With number 1 here, it's basically saying the depreciation value of this car. It depreciates by 12,300 every year, and it starts out being worth 86,100. Okay, so that's what somebody might have bought the car for, and then every year the car goes down in value by 12,300. So we start off with that initial value, and then we subtract off 12,300 for every year, and that's why we do the 12,300 times x. Okay, and now the A says what's the car worth in 5 years, so we just plug 5 in for x, and then we'll see what it's worth after 5 years has passed. Okay, so I'm just kind of running through and multiplying that 5 times the 12,300. Then we'll go ahead and subtract here. And so after 5 years, the car is now only worth 24,500. So it's decreased by more than half of its value. So 5 years goes by and the car is worth less than half as much. So it really is depreciating a lot. So for B, we plug in 10 for x. To see what's happening after 10 years. After 10 years, the car is not worth anything, is what it says, or at least says that it's a negative value. But we can't have a negative value, right? We can't have a car being worth a negative amount of money. So we just say that I guess it's worth nothing at that point. So after 10 years, the car is not worth anything. Okay. C says, though, when is the car worth 0? Well, we just found out that it's worth 0 after 10 years, but hey, maybe it's worth nothing before then. So let's figure out if it's worth nothing at some point before 10 years. So we plug in 0 here because that's what we want to find out. We want to see when the car is worth nothing. So we go ahead and plug in when it's worth nothing and go ahead and solve for x. So that first step, I'm just subtracting 86,100. Okay, so I subtract that from one side into the other, and so on the left hand side of the equal sign we have negative 86,100 equals negative 12,300 times x. So we're going to have to divide by this negative 12,300. We do that to the one side so that they cancel, and then we do that to the other side. Okay. Now we go ahead and evaluate that, and all we're left with is x because these cancel over here. So we have x equals, and if you divide these two, that equals 7. So after 7 years, so 7 years later after you first bought the car, it's going to be worth nothing. So that's a pretty bad depreciation value there. Alright, so we can move on to number 2. So number 2, we're saying that some population of the U.S. Grew by 9.6% each year. So let's go ahead and get down the formula for growth or exponential growth or whatever. So we have this P star value, and that's what I'm using to just kind of call what our population is after a certain amount of time. So P star is the population after time, like after T time has passed. Okay. So now we have not the P star, just the P value, and that represents the initial population, like what we started off with before we start going, years down the road. So like in the last problem, the initial value was for the car was like 86,000. Okay, this is initial population, so it's very similar. Okay, so R is the rate or the percent turned into a decimal. So like in this case we have 9.6%. So I think our rate will be 0.096. And then the t is, of course, just the time, usually calculated in years, but not always. We'll see further down the road that it's calculated in months sometimes. It just depends. Okay. So we do A here, and it says, how many Hispanic Americans were living in the U.S. in 2000? So they want to know the initial value, and they gave you, 10 years later, 10 years down the road, they gave you the value for that. So what we can do is we plug in, the population after t years, which is 55,000, whatever. And remember, that was after 10 years, right? So that's why we plug in 10 up there. And so now we're trying to solve for our initial population here, because that's what it says. How many Americans were living in, or Hispanic Americans were in 2000, and it gave us the number for 2010. So we want to go ahead and plug in 10 years, because there's 10 years from 2000 till 2010. Okay, so we're just kind of plugging in all the different values where they match up in this formula. Okay, so we would just have to divide by 2.5 to solve for p, and that's just after I've evaluated all of these these numbers in here. Yeah, so just go ahead and divide by 2.5, and we will go ahead and get an answer there. I think our answer was something along the lines of like 22 million. Okay, so now we can create a model for any time in the population, so we can know what it is 10, 20, 30, 40, 50 years down the road, doesn't matter. So we say that P star, that's the population after t amount of years. We say P star equals the initial population, which we just found in problem A, and then that's times the 1 plus the rate, and then we have t in there so that we can plug in any amount of years and get a population amount. So for C, it has us solving for what the population is in 2020. Well, in 2020, that's 20 years after the year 2000, and the year 2000 is where we have our initial population. So we plug in 20 for t because 20 years has passed. Okay, and then we just solve. We would just plug in 20 right there. We'd do 1 plus 0.096 to the 20th, multiply that by 22 million, and we'd have some answer. Okay, so I'm going to let you go ahead and solve for that on your own.